Welcome to Real Civil YouTube channel. In this video, I am going to show you uh, the check related to the P delta effect using ETABS software. Will require one simple Excel sheet and some theory. The P delta analysis or effect, uh, the formula is given in ASCE 716 and ASCE 722. That is the stability coefficient for story x. Okay, so this is the formula basically. Theta x is equal to px delta e vx h sx. Okay, so there is a condition related to this theta. Before that, we will see px is the total design vertical load at and above story x, and for that in ETABS software we need to run one load combination case, that is 1.2 dead load plus 1 live load plus 0.2 snow load. Okay, if you don't have snow load, no problem. And many times engineers says, or they are using factor 1 for dead load, so you can run the case dead load plus live load. One combination case is required to be run. Then delta is first order elastic story drift occurring simultaneously with Vx, that is raw displacement output from linear static analysis without multiplying by CD. So here we will require our seismic analysis case, and what is the story drift, like EQX case will be there. Then total seismic shear force, and then story height below level X. So these are the parameters, and there is a condition. The limit is given. The limit is given for the theta. First condition is our theta x, which we have calculated from above formula, is less than 0.1. Then you can ignore the P delta. That means there is no need to uh, consider the P delta effect, or it is very small enough that they can be neglected. So no amplification of the force or drift is required. So whatever results are there, you can accept as it is without running the P delta case or without amplifying the results. The second case is your theta, which you have calculated, is in between 0.1 and theta max. Okay, if it is falls between 0.1 and maximum allowable limit, then you must include the P delta. Okay, P delta effect. For that purpose, you can basically go for, or you have two ways. The first way is you can do linear amplification, means you just need to multiply the member forces and story drift by this factor. The formula is given 1 upon 1 minus theta x. You have to, whatever factor will come here, you have to multiply all the forces with this factor. Or you can use, or you can directly go for P delta analysis. Just run a non-linear P delta elastic analysis in your software. So there are two ways. So in first case, if theta is less than 0.1, then there is no need. If it is between theta max and 0.1, if it is in between, then you have to go for the, or you have to consider the P delta effect, either by linear amplification or either by direct running the P delta analysis in the software. There is third case also, that is theta is greater than theta max. So in such a case, the structure is considered potentially unstable under the dynamic loading. The building fail the code check and must be redesigned to increase its lateral stiffness. So this in this case, you have to increase the lateral stiffness. That is our third case. So I hope the formula and these three cases are clear to you. Now I am going to show you how to use this formula in Excel sheet and how to extract the information from ETABS software to run the Excel sheet. So the first parameter is story. In ETABS software, you can basically get your stories here. So just copy these stories and paste here. Okay, terrace, 5th floor. So these are my stories. Next, will require the height, that is story height. So you can get the story height from here. The story height here is in meter. Here we put in mm. Okay, so you just put the values, the story height, the respective story height. Now we will require p. As you can see in this formula, we required p. For that, as I told you, you need to run the load combination, dead load plus live load. So dead load means self-weight of the structure. You have to consider the superimposed dead load like floor finish, wall load, etc., proofing, and live load. Okay, so you have to consider this. Either you can go for 1.2 or even you can go for dead load plus live load. That case you need to run. Okay, after that, to get the p, go to analysis result. Here structure output, other output. Here there is a story forces. So right click, show table. Here we will select the our case, which is dead load plus live load. Right here, consider bottom, and here you will get a p values. Okay, you just need to copy these values and paste it here. So this is your p column is ready. Now Vx. For Vx, here we will select the EQX case, that is your lateral case, and we'll select the that you can check for all the cases 1, 2, and 3. Okay, so you have to select the earthquake case, whatever name you have given, static equivalent static response spectrum case, and you have to select this column, that is Vx, shear force in global x direction. You have to check for both EQX, EQY. I am showing for EQX only. Okay, so I have pasted the Vx here. Then we will require story drift. Before that, we will calculate or we will see the displacements. So for that, just a minute. Here, joint output, displacement, diaphragm center of mass displacement. Again, here you can select your case EQX1. You can select your step number 3, or you can check for all. Here the UX is given. You just need to paste it here. Okay. Now, in our formula, I think Px, Vx, and Hx are already there. Delta E is elastic story drift. So here I have applied the formula for the story drift. Okay, that is 2 minus 3 will be the value here. Similarly, for this case, fifth floor drift displacement minus fourth floor displacement will give me the drift here. So accordingly, I have calculated the delta here, and now you just need to apply this formula in your Excel sheet. You will get the values of theta. Okay, and you have to compare this theta with the first with theta max. So this is the formula for the theta max. Theta max 0.5 beta into CD should be less than or equal to 0.25. So this is the maximum theta formula. So CD values are given in ASCE code, and beta value is generally kept 1. So you can get theta max. Okay. So you can see here, beta is the ratio of shear demand to shear capacity for the story between level X and level X minus 1, and generally it is kept as a 1. So which simplifies the equation, and CD is deflection amplification factor, which is available in ASCE table 12.2.1. So from that you can calculate the theta max. In our case, theta max is comes out to be 0.125. Okay. So if you see the Excel sheet, all these values are less than 0.1, but in last case here the value is just crossing 0.10, but it is below 0.125. That means this is my maximum. Okay, theta max. So I have to uh, go for p delta analysis, or I can, whatever results I got from like forces and drifts, I need to multiply here by 1 upon 1 minus 0.120, sorry, 0. Whatever the value of the theta is there, that is 0.1096. That will be my multiplication factor, or I can simply go for non-linear p delta analysis in ETABS software. And suppose in any case my theta is greater than 0.125, then my structure is unstable and it fails. So in that case I have to redesign to increase the stiffness. So I hope the concept related to the P delta effect is clear. If you have any doubt, you can ask me in the comment box. I can share this Excel sheet also with you. Thank you. Please like, share, subscribe the channel. Thank you so much.